Hi folks. In the last short video, I discussed about the linear power supplies and how they operate, and the much lower efficiency and the high ripple factors in that were the basic fundamental constants. So today I will start discussing the switching power supplies. Switching power supplies basically comes in two configurations. One is the non-oscillated version, in which the input-output ground is common, and the other is the isolated version or isolated configuration of the switching power supplies, in which a transformer, high frequency transformer, is used in between input and output path, and the input and output ground are not common and they are separated. Normally the isolated version is used when we need to connect it to the mains input voltage of 220 volt AC, and the output voltage is much lower DC voltage. So the first non-isolated version of the switching power supply is called the buck converter, and I will discuss with you the buck converter in today's short video. Buck converter is a step-down converter like the linear regulator, and I mean the input voltage should be higher than the desired output voltage. Buck converter consists of a few basic fundamental components. I mean input filter capacitor, and then a series high side switch, and then the output inductor, and then the filter capacitors at output side, and a freewheeling diode in between the inductor and the high side switch, whose other point is connected to the common ground. The buck converter can be operated theoretically up to 100%. However, due to some limitations like the current sensing requirement and the bootstrapping requirement of the high side MOSFET, it limits its duty ratio less than 100%. When designing the buck converter components, we have to consider that at what input voltage range we insert the values in the formulas. So in designing the, for example, in designing the inductor, we normally calculate the inductor value at the maximum input voltage range. It is because the inductor current consists of the peak current and which on the other hand consists of the DC current and the AC ripple current. Although DC current is maybe a constant value, but the AC current increases with the input voltage. So at maximum input voltage we calculate the inductor. Similarly, output capacitor is also calculated at the maximum input voltage, because the AC ripple is maximum at the maximum input voltage, and it is the other reason is that it is adjacent to the inductor. So as long as the input capacitor is concerned, it is calculated at the 50% duty ratio value of the input voltage. Because at the 50% duty ratio, the input current ramp is a rising ramp and a falling ramp are at the higher peak values. As long as the series high side switch or the MOSFET is concerned, its value is calculated at the minimum input voltage, because at minimum input voltage it has to pass the maximum maximum current through it to fulfill the demands of the power ratings of the device, of the module. As long as the freewheeling diode is concerned, it is also calculated as the maximum input voltage, because normally the current passes through the high side switch or the MOSFET, but when the switch is turned off, the diode is turned on to freewheel the remaining current of the inductor. and at higher input voltage, because at higher input voltage the duty ratio is minimum, and the minimum duty ratio means that the switch is turned on for the short duration, and the remaining duration the diode is turned on, and that's why its value is calculated, rating is calculated at the higher input voltage. Then the ripple factor, as long as ripple factor is considered, then we calculate the inductor at 30 to 50% ripple factor, and this ripple factor is enough for the buck converter to convert into the less than 1% or 1% ripple using the output filter capacitors. This was our today's discussion about the buck converter, and concluding that the buck converter is a step down converter, and it can be theoretically operated up to 100% duty ratio. And as I told you that the calculation of the different parts of the buck converter depends on the input voltage range, and whether we have to use the maximum input voltage or the minimum input voltage depends on the desired parts. I mean, it is different for the switch and the diode, and similarly input output capacitor and the inductor. So this was our today's discussion, and stay connected, and thank you very much.